We have another fun one. Here we go. I see a GCF and so do you. So let's go ahead and set this equal to 0. And then we're going to factor that GCF out, which gives me x to the third. We're going to write very quietly this time. There we go. So if we took x to the third and set it equal to 0, and I'm going to skip some space because of the magic that's about to have to take place here. X to the third equals 0. Then x would equal 0, but it would be a triple root. So, all right, let's think about what we've learned. If I were to graph this, and I will, if I were to graph this at the origin, I would have a triple root. Actually, I might have one that goes this way. It's actually this way. I don't know why I'm whispering about it, but that's the way it is. There we go. So we're going to have x equals 0, and we have already found 3 of our 6 solutions, even though we've only found really 1. So final answers, x equals 0, and I'm just going to put it has a multiplicity of 3. So that is not 0 multiplied by 3. That is 0, 0, 0. I'm listing my roots, even if I have to repeat it in this case. So 0 with a multiplicity of 3. You don't have to do that every time, but I don't want us to lose count of the fact that we're really looking for 6 of them, and we've already found 3. So we're still looking for 3 more. All right, let's keep factoring. X cubed, don't forget it, process. This is the difference of cubes. So I'm going to have x minus 2, x squared plus 2x, plus 4, always positive. There we go. We're going to set that equal to 0. And we're going to set each of these factors equal to 0, which we've already done for the first one, the GCF. Now we're going to set x minus 2 equal to 0, and x will equal 2, which means we now have a 4th answer. And now we are looking for 2 more. And we're going to get those 2 more right here. And it's going to get fun. So I might not have enough room, so I'm going to scooch this over and switch colors again. Let's go purple. Quadratic formula. It's quadratic. Try factoring that. Just try it. Just try it. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Let's make that square root go where it needs to go. And that's going to give me negative b plus or minus the square root of b squared minus 4 times a times c. Here's a, b, and c, all divided by 2 times 1. You can leave those 1s out if you like. Come on, you're going to slide up. There we go. Negative 2 plus or minus. All right, 2 squared minus 16. So 4 minus 16 is negative 12. Let's try this again. Square root of negative 12, all divided by 2. Oh, we have a negative under a square root, so we're going to have complex solutions. And we're going to have 2 of them. Complex solutions come in pairs, plus and minus. So we'll have negative 2, I mean, plus or minus. All right, let's take a moment in what color? Red, to figure out what the square root of negative 12 is. So somewhere on your paper, if you need to doodle this, you can. The square root of 12 is 4 times 3, square root of 4 times square root of 3. And because of the negative, there's an I involved. The square root of 4 is 2. There is an I involved. And there's that. You could say that I is equal to the square root of negative 1. At this step, I did not. So 2i square root of 3. You have seen that before. 2i square root of 3. We're now going to reduce. Everything is divisible by 2, so we'll reduce. Let's use red again. 2 goes into itself 1 time. Negative 2 is divisible by 2. It goes negative 1 times, and then this is a 1 there. So the next line would say negative 1 plus or minus 1i square root of 3 all over 1, which means final answer, green over on the side, is going to be these 4 things, 0, 0, 0, 2, and negative 1 plus I square root of 3, and negative 1 minus I square root of 3. And those are our 6 solutions. Let's get a visual for what this thing looks like. By the way, just giving you a heads up, x-intercept here at a triple root, we talked about it, it's that funky thing. Single root here, no x-intercepts at all. They won't show up. Held up 10 fingers because they won't show up. All right, let's see what it looks like. Isn't that lovely? Triple root, single root, there's 4 of them. The other 2 are hiding, and you had to find them algebraically.